Hi, this is Professor Rafael talking about hypothesis test for the difference between two population means when I know the standard population standard deviation. Okay, so this is the second video in this discussion, and I'm stopping here in the hypothesis development. And I was going over some problems in our book, so you can understand a little bit more about the development of this hypothesis. This is very important. You have to understand how to come up with them. And what I showed you was this process, let's say lower tail. And then I showed you one example. Let's take a look at one more. So let's talk about upper tail. Upper tail would be something like, let's take a look. This one is upper tail. So I'm going to do that. The difference in the means for the null hypothesis is that they're smaller than a hypothesized number. This hypothesized number is 0, so I can delete this part, only the D0. And then I have for the alternatives that the difference is higher than a hypothesized number, in this case 0. So what I really could do is I could show that this hypothesis is something like mu1 is smaller or equal than mu2 for the null. For the alternative, the mu1 is higher than mu2. Okay, so this format with the means in each side of the inequality is the same thing of this one, but instead of having the zeros, I would have something like 0 and 0. Okay, so this is how this hypothesis with zeros here could translate into this format, which has the means in each side, which in my opinion is easier to understand when you read the problem. Let's take a look at this one. Suppose that you are responsible for making arrangements for a business convention and that you have been charged with choosing a city for the convention. Okay, you have narrowed your choices to Atlanta and Houston. You have the data of named hotels which contain a sample of prices for rooms in Atlanta and Houston, and that they're consistent with the results reported by whatever. Because considerable historical data on the prices of rooms in both cities are available, we know the population standard deviation. These words are very important. They're key for you to know that you are working with the z-score. Because when you know the population's standard deviation, you use the z-score. Okay, so this is a key word here, very important. For the prices, can be assumed to be 20 in Atlanta and 25 in Houston. Based on the sample data, can you conclude that the mean price of a hotel room in Atlanta is lower than a hotel room in Houston? Okay, so let's call mu in Atlanta is 1 and mu in Houston is 2. Okay, so the mean in Houston and the mean in Atlanta, what we have is okay, we have to use the data. The statement of the problem doesn't give us the means, but gives us the data. So let's say we use the data and we have, I don't know, let's say for Atlanta is 150, for Houston is 180. So I have to come up with the hypothesis, okay? And if I read the problem says, can you conclude that the mean price of a hotel room in Atlanta is lower? This is the keyword, is lower than in Houston. So when I go back here, I want to test this. This is what I want to test. if this is what I want to test, this is my question, that's the alternative. So mu in Houston is lower than the mu in, the mu in Atlanta is lower than the mu in Houston. Price in Atlanta is lower than in Houston. Atlanta is lower than in Houston. That's my alternative. This is what I want to test. This is what I don't know. So I have to assume that prices in Atlanta are higher than the prices in Houston. Okay? So this is how I turn. This is not this kind of problem, because you see that, let's wait for it shows up on screen. Okay, so you see that this format is different than this format, but unfortunately I don't have a problem here that is in the other side. But what I want to highlight is that by reading lower, increase, higher, and so on, you can set up the means and then set up the hypothesis properly. Okay, so that's something that is very important. All right, then after do that, I propose two approaches. I propose my steps of hypothesis testing using approach 1, which is the critical value approach, and approach 2, which is the p-value approach. You had similar approaches in chapter 9, okay? So the approaches here are very similar until like step 1 and 2 are the same. Develop the null and alternative hypothesis, determine if it's a lower, upper, or true tail. This is the reason I spend a lot of time talking about this one, because depending on how the alternative hypothesis is designed, you know that if it is lower, upper, and true tail. Okay, and then specify the level of significance alpha. You know, you went through this in chapter 9. That's very similar. And then we use that to get the z using the alpha you found here and this formula. So you have the z critical. You collect the sample data to compute the test of the test statistic z, and then you compare both to see for the lower tail test, which is given in this step, if it is smaller than z critical, we reject the null hypothesis. If it is upper tail and the z statistic is higher than the z critical, you reject the null hypothesis. And if it's a true tail, if the z is smaller or higher than the z critical, then we reject the null hypothesis. Okay. Let's take a look at this process first before I move on to the next one. Okay. So we have the training centers, the problem we discussed before. These are the sample means and all information. So let me use my steps here to solve this problem. So let's go. Step number 1. Develop the null and alternative hypothesis. So let me read the problem again. Can we conclude that no difference exists between the training quality provided at 2 centers? No difference. So when I go to formulation hypothesis, I have the no differences here, which means equal. So mu1 is equal to mu2. And the other one is that the mean in one training center is different than the quality in another training center. This is the same thing as having a null hypothesis like mu1 minus mu2 is equal to 0. And the alternative is that mu1 minus mu2 is different than 0. Okay, so I know that this is true tail. True tail. Step number 2 is true tail. That's right here. Develop the null alternative, determine if this upper is true tail, specify the level of significance. So step number 3, let's see what the problem says. The problem doesn't say, okay, gives us the alpha here, 0.05. So step 3 is specify the level, the alpha 0.05. Okay. Then if lower tail, that's not the case. If upper tail, is not the case. If it's two tail. Two tail do alpha divided by 2. So this is two tail. So I do alpha divided by 2, which is 0.025. Okay. And perform steps 3.1. 3.1, use as it is. So this is one of the alphas. Alpha, lower tail, alpha, lower tail, and if upper tail, do 1 minus. So if I do 1 minus 0.25, which is equal to 0.975, this is my alpha upper tail. Okay, so I have the two alphas, upper and lower tail. Find the z critical. So my z criticals here are step number 4. Z lower is going to be equal to norm.s inverse 0.025, and my z upper equal norm s inverse 0.975. Okay, so I add the two z scores, and I believe is minus 1.96 and 1.96, negative and positive 1.96. Okay, I found the z's. Now collect the sample data and compute the value of test statistic. I have this right here. Compute the value of the test statistic. You simply apply the formula. I'm not going to copy the formula. So if you copy the formula, plug the numbers in, simply look and plug, you get the z-score of 1.66. So step number 5, z is equal to 1.66. This is z critical. Okay, so these are z critical, and this is my z, my test statistic. Okay, now I have that. So you see I did all the steps up to this point. Now I have to compare the z from this step with the z critical. Is two tail. So z is z smaller. So if I come here, step number 6, let's do one more here. Step number final step, step number 6. It is a two tail. So is z smaller than z critical? First question is if z is smaller. So let's take a look again. My z is 1.66. Is not smaller than this, right? Is higher. So I can, nope. Then the second question, because it's a two-tail question. If it's one-tail question, it's just one question. Because it's a two-tail question, is it smaller or is higher than the z critical? So I go back here. This is 1, 2. Is z higher than z critical? Let's take a look again. 1.66, this number right here, is not higher than this. Sorry. It's not higher, so no. No. So it's not smaller and it's not higher. What my step says, if it is smaller or higher, then reject. So it's not smaller and not higher. So fail to reject. Fail to reject the null hypothesis. Okay, that's it.